So our next speaker is Kieran Jacobsen, and I remember Kieran's talk from CrikeyCon 1 actually, because he did a PowerShell talk back when PowerShell stuff was really still like horrible. Back when I think we just mentioned it on the show recently about how then you could just people would add script protection so that you could only run signed PowerShell scripts, and Microsoft set this up in such a way that if this was bothering you, you could just turn off script checking. It was a horror show talk from someone who really Kieran was at that point a Windows guy, right? So today he's doing something called the boring security talk. And I'm going to read from the abstract here. He says, "We all know that securing our applications is a necessity, but it can be incredibly boring. With time and budget constraints, we often focus on the more exciting security aspects and tools. But in this talk, we'll be looking at some of the aspects to our application security that are often overlooked. The software that we depend on, CI/CD infrastructure, sending email and resolving DNS, a la the basics." Now, Kieran Jacobsen is the head of IT at Redify and a Microsoft MVP, and we're going to bring him up now and get him to start his talk. It's Kieran Jacobsen.
So good afternoon, everybody. My name's Kieran Jacobsen. This is actually my fourth CrikeyCon conference, fourth time speaking to you all. And it's a pleasure to return every year and to talk about various epic things. Last time I was at CrikeyCon, I spoke about DevSecOps. A lot of that content was built upon my experiences of DevOps and DevSecOps within my own team. Today's content is a bit of an extension of a lot of the stuff that I've been working on in that sort of respects. I want to talk about things that often get overlooked. And a lot of this stuff came about from acquisition processes and things as well. Things like protecting your CI/CD infrastructure, email security practices or bad practices, DNS management, and then understanding what happens when dependencies within your software stack go bad. So CI/CD systems, in a DevOps world, they're the heart of a smooth running organization. They're a mission critical aspect to our infrastructure. But has anyone in the room ever considered the chaos that an attacker could get up to if they'd owned this infrastructure? Your TeamCity, your Octopus, your Jenkins. I see a lot of badly set up infrastructure, and so let's take a look at some of those common issues. People love to overshare on the internet, is my usual statement. It's common to see the startups and smaller, less mature organizations operating entirely in the cloud and exposing the management interfaces and the API interfaces of their CI/CD infrastructure to the internet. We're not talking about SaaS offerings like Azure DevOps or GitLab here. We're talking about your TeamCity, your Octopus, your Jenkins. There's a lot of authentication mistakes going on. The lack of HTTPS is probably the biggest by far, but that's not going to get you owned as such. The use of shared accounts or generic accounts is very common. This is, in most cases, a licensing violation and not just a security issue. You're destroying your audit trails in the process. You're losing the ability of knowing who's pushed what to production. When named accounts are being used, stale accounts are really common. Systems where the developers who had access, they've long since left the company, they're off somewhere else, yet there's accounts on the CI/CD infrastructure are still active. There's endless stories of disgruntled employees coming back and trashing environments, and a CI/CD system would be a great place to do that sort of activity. The lack of MFA is another problem. It's one of the strongest defenses against credential spraying attacks. We're not really seeing those directed at CI/CD infrastructure, but it only is a matter of time. I'm often contacted by consultants working in heavily locked down networks. The devs don't have admin rights in production. Some cases they don't have it in dev or even on their own workstations. The security teams are super happy that they've locked everything down. What they haven't realized though is there's a really big hole in their security model. The devs have admin rights on the CI/CD infrastructure. That infrastructure has admin rights on prod. So in essence, the developers do have admin access to production. Now, how does this happen? There's a bunch of different ways. I see with AWS cloud, the keys are given far too much access to too many resources and too many actions. That's a big one I'm seeing these days. How do I put this in a family-friendly way? I really don't understand why patching is so hard anymore. You've got OS patching plans, but you might be running old versions of CI/CD tools. And we saw this yesterday with the talk about IDEs of March. There's old versions of those tools and Git and your compilers and stuff that are out there and can hurt you. For those of you running Jenkins in your environment, how comfortable are you that all of your instances are actually up to date? It's had a really rough year with security patches. Are they all up to date? So in February last year, hackers exploited vulnerabilities in Jenkins to make over $3 million mining Monero. They were successful for the sheer fact that there's so many Jenkins servers that are exposed to the internet. And from experience, these instances have quite a lot of computing power associated with them. What shocks me with this case is that no one really noticed that their builds and deployments were taking longer. Maybe they did and they just upped the amount of resources on the instances. I don't know. Think about your environment. If you're running these cloud instances, would you have noticed this happening? Or would it have been the bill shock when you get your Azure or your AWS bill and you go, why is it $60,000 for the month? Would that be heavier monitoring? So how do we start to protect against these attacks? So Network Security 101 tells us we should be restricting access where possible. Do you need to expose your CI/CD systems to the internet? If your development and production environments are totally within the corporate network and it's all locked down, then maybe it doesn't need to be accessible via the internet. If it does need to be, can you restrict it down to, say, a set of trusted IP addresses? Your secure server IP addresses, your office IPs, a VPN endpoint. If you can't do that, can you at least restrict what destination ports you can connect to? If it's something like Jenkins, you might have HTTPS management, you might have SSH to manage the server. You don't really need FTP or Telnet or anything else open to the internet. Authentication and privileged access has to occur over HTTPS. It can't occur over plain text protocols. Certificates are easy to obtain now. There's no excuse. And don't be lazy and use self-signed certificates. Users should have their own accounts, no shared accounts. Personal preference is to use something like SSO. I don't care if it's Azure AD or OpenLDAP or any of those sorts of things. Just use a centralized identity provider. The benefits of SSO are better auditing, monitoring, and user account provisioning and deprovisioning. If your CI/CD systems are exposed to the internet, my personal sort of belief is that MFA is mandatory. You don't get a choice out of that one. It has to be enabled. Quick side comment here. If you're making an application or you're a vendor that's supplying applications and you don't support SSO or MFA in 2019, or you're going to try and charge me extra for it, I am actively looking at replacing your products within my environment. I don't want your insecure crap in my environment anymore. That's just the way I'm running things now. Your CI/CD systems, your service accounts need to run with the least privileges possible. Avoid local system and root on Windows and Linux. If you're running within an Active Directory environment, don't run as domain admin. Don't run as enterprise admin. Use standard user accounts where possible. Restrict your AWS keys to only the resources and the actions they need to perform. Azure security should be assigned at a resource or a resource group level, not at a subscription level. Think about restricting access to your CI/CD infrastructure. That junior dev that only needs to view the status of builds doesn't need admin access. Build a patching plan that includes all of the tools in your developer chain. IDEs, dev tools, compilers, packaging software, and your CI/CD components. You've already got OS patching plans. You just need to extend it to the rest of the software stack. So one little interesting story about CI/CD from 2017. And there are actually bots that were going through GitHub and would hunt for projects that used CI for pull request validation. They would then replace the code of the project with Bitcoin mining code and, of course, create a pull request. And then, of course, that code would then be automatically run as part of the PR validation process. We all love these automated builds that trigger off. They decided they could mine Bitcoin via it. They were pretty quickly shut down via GitHub. They put controls in place to prevent this from happening. But once again, how would you detect this attack in your environment? Would it be bill shock again that's your monitoring mechanism for these styles of attack? DNS. It's a critical system that never gets the attention it deserves. Every organization relies on DNS, yet we really don't think about it as much as we do, say, printing or email. And that's a big downfall to most organizations, as we've seen in the last few months. And so what are some of the challenges that I see with organizations managing their DNS? Organizations really struggle understanding what DNS entries they have, why they're there, when were they created, when were they modified. Was that entry added by an attacker or a legitimate administrator with approval? Now, if you're sitting here and you're working in an environment with, say, change management like ITIL, you might be feeling a little smug right now. You're probably thinking, well, we've got change forms, we've got request processes, we know everything that's happening in our environment. Two challenges for you when you go back to work. Does your change request process actually fully describe what the change is and why? And secondly, if I was to get your DNS zone and randomly point at one entry, could you tell me who created it, why they created it, and when they created it? Would that process take 5 minutes? Would it take an hour, a day, a week, a month? During a security incident, time will matter in how you can answer these questions, particularly around DNS. If you think that an attacker has created that entry and you're about to delete it, how do you know that it's not your legitimate production service that you're about to delete the DNS entries for? The next challenge is around the speed at which we now need to make DNS changes. In the past, they probably happened once, maybe twice a year by a system engineer or a network engineer as part of some sort of application upgrade cycle. Records were pretty static for years at a time. Things are changing now. We want faster application release cycles, we want daily releases, we want DevOps. Yet, a lot of organizations really haven't changed their approach to managing DNS. We've still got ops teams going into a console and making the changes manually. And this leads to a bunch of different problems, and the obvious thing is that there's a bottleneck. It's going to take more time to make those changes. If I had $1 for every outage that was caused by DNS, I'd probably be driving an expensive sports car and have my own private jet. Why do these challenges occur? Well, it's often just a simple issue of visibility. Those impacted by a DNS change are often the last to know it's happening, or they often find out after the fact. This is another point where change management really should have helped us with this visibility problem, but in my experience, DNS changes tend to get hidden in the process. They're low priority changes, they're low visibility changes, or low risk, and so people aren't aware that we're about to change the IP addresses of the DNS entries of the mail servers, that everything in our environment needs to connect to. With the move to providers like Cloudflare or Azure or Route 53 by AWS, more organizations are actually outsourcing the hosting of their external DNS. This has actually improved availability in DNS services, but it introduces some other sources of problems. The main mechanism for managing these platforms is typically some sort of web interface. There's often APIs and other management services, but left to their own devices, a lot of organizations will just drift to that web experience. The biggest issue with these interfaces is transposition errors. You've got your change request or the email request, you make a change, you copy and paste, you miss a character, Instead of webmail, it's webmail or something, and all of a sudden, no one can get to the service, or we manually type an IP address in and we type an 8 instead of a 9, and all of a sudden prod goes down. All of these interfaces are different. They use different terminology, and that is another contributing factor to configuration issues. Things like, do we use a blank to refer to the root of the DNS zone, or an @ symbol, or an underscore? What terminology do we use? A big part of it is that we need a standard method for working with DNS across multiple providers. And attacks against DNS are becoming more and more popular, especially in the last few months. In January, there were reports of multiple US government domains being hit by DNS hijacking. Things went as far as for DHS and GCHQ to release directives warning about these risks and telling people what steps or what actions they needed to take. This is rare for these sorts of organizations to release these sorts of directives. This is the first for DHS, the second for GCHQ, the only other one being WannaCry for them. Dangling DNS entries are another major problem, particularly when cloud infrastructure is being used. Situations where DNS records, particularly CNAMEs, they're created, they point to some sort of cloud service, days, weeks, months go by. Those cloud services are deleted, but those original CNAME records remain. Microsoft actually got hit by this in 2017. resnet.microsoft.com was a CNAME to resnet-prod.azurewebsites.net. A couple of months later, somebody deleted that Azure website. But those entries remained. A security researcher discovered it, alerted them, they fixed the problem. But all it would have taken was one attacker creating an Azure App Service with the name resnet portal-prod, and they would have been able to hijack a Microsoft subdomain. Think about the effectiveness of a phishing campaign that was actually a Microsoft subdomain. That would probably be like a 90% success rate, 95% maybe. So what tools can we start to use to streamline DNS management and reduce these errors? So DNS Control is an open source tool written in Go and maintained by the Stack Overflow team. And it allows you to preview changes before pushing them to your DNS provider. At Redify, we've been using DNS Control for about a year now. Anyone at Redify can propose a DNS change, and one of our platforms team can then go and review it, approve it, merge it to master, and it's pushed to production. This empowers developers to create changes. They can then go and clean up records as they decommission infrastructure. And we've removed my team as a bottleneck. So how does it help? Sorry. How does it help us solve some of these challenges? So it uses JavaScript to define a simple format that can be understood by everybody. We can all propose and review and understand changes. You don't need to be a JavaScript expert. I have no idea about what JavaScript is or does. I'm an ops background, and yet I've had no problems writing zones. The screenshot here is a piece from a public zone that I maintain for Planet PowerShell. You can see how easy it is to understand what's an A record, a text record, a CNAME. With the human readable format, you should also be able to add comments that describe the contents of the zone. This is production, this is development, this is a staging slot. These are our mail servers. So now you can start to actually answer those questions of what's that record actually for. Git and version control systems, they're another core piece of this DNS management puzzle. We store our DNS control files in Git. It gives us a history of all the changes in our zone and who made those changes. Git branches, they're easy to create and merge, and they allow developers and engineers to make changes and push them into production easily. Git becomes your change tracking tool. Git log, Git blame, you use those to work out what changes just been made that broke prod and who made that change. Platforms like GitHub and Azure DevOps, they extend our Git experience with pull requests. These are they're like change requests in ITIL, but they're faster to create, they're easier to read and understand, and you don't need a meeting to get them approved. They shine a light on changes in a way that ITIL promised us and has never delivered. You can include the teams and the individuals that might be impacted for approval. If you know that your change for the MX records is going to impact your mail servers, then maybe you include the email support teams, the security teams, and the desktop mobile support teams as well. They can all read the change and then approve it and acknowledge they know what's going on. CI/CD is the final piece to this puzzle, and it removes the risks of human-generated errors. We can run DNS controls preview function for all of our pull requests, and that way we can validate the changes and report on what actions it's going to make when we push to prod. This gives us more confidence in the changes being made. Once a PR is approved, the changes are merged to production, and our CD process will use the push functionality to push those changes into our DNS platforms. So as you can see here, we've changed our DNS management flow from something that requires a lot of human interaction to something that's fully automated. We've sped up DNS changes from from days to minutes. So before I finish, one little example that's actually in the wild, and you can play along at that link down the bottom. Here we can see a page on Dell's website, and it's talking about their hardware-based encryption. The page has links to white papers and case studies, trying to encourage us to buy their product. So let's assume that I'm interested in the Trusted Computing Guide. I'm going to click hover over the little link in the bottom left corner and see where it goes. So it goes to a website called dellforslg.com. I worked out that used to stand for Dell for State and Local Government. It was a website targeted to those groups, had quite a lot of content around security stuff in the past. What happens if I click on that link? That's not the Dell website. That's a plumbing supply store in Turkey. It seems that somebody noticed the domain wasn't renewed and decided to renew the domain or buy the domain and set up a fun little traffic redirector. So anything on the Dell website that actually references dellforslg.com now goes to the Turkish plumbing supply store. Your domains are part of your organization's brands. You need to take the same steps as you would protecting your logo or your typeset and your background colors on your website to your email domains and to your DNS domains. As an industry, we'd love to think that we're getting rid of email. The truth is that even if you're using Slack for all your internal communications, email is what you're using to communicate to your customers, your vendors, and your suppliers. We use email activities for things like account creations, confirmations, password resets. Considering how important our email is to our business, it really doesn't appear that many organizations have taken the steps to ensure that our recipients of those emails can verify them as being legitimate. Where do I start with what's wrong with email these days? Email-based attacks like spam and phishing and everything else are on the increase. There's more stories of successful whaling-style attacks against executives and high-profile targets within organizations. They'll come as some sort of formal, legal subpoena or customer complaint, and they're really, really good at hooking, your executives, your CEOs, and things like that. And they're really good at preying on those targets. I think by now we've all heard about some of the various executive impersonation attacks. These are where, say, the attackers are posed as like the CEO. They send an email to, say, the admin or finance teams or their personal assistant saying, hey, I've got this urgent request to transfer money to this person or this country to complete a business takeover or some sort of business transaction, or hey, I need to buy iTunes gift cards to reward customers for their, business to us. These attacks create a sense of urgency, and they're coming from people that we rarely question, and that's why they're so successful. My frustration with all of this is that we can actually make these attacks harder. We can't prevent them, but we can make them more difficult. But most organizations don't seem to care about doing this. They don't seem to want to put those controls in place. So here's an email that's been sent from Have I Been Pwned. We're probably all nervous about when we get these emails. Every message is made up of two parts. We've got our headers. They're basically key value pairs providing delivery and diagnostic information. And then we've got the message body. That's the bit of the email we actually want to read. So there's two headers that cause a lot of confusion, and they're all to do with the from, who the message is from. And the problem is that when we send a message using SMTP, we actually specify who the message is from twice in the communication. When the SMTP connection is built, the sending SMTP client specifies the sender's email address. We often call this the envelope from or SMTP from. Later on in the mail headers, the client will also specify the sender again, and this is often called the message header or the from field. The message from or the header from field. It's this one that mail clients display to the user when they open that email. These two headers don't actually need to match. Platforms like SendGrid will often use different entries to track bounce rates and do redirects and things like that. They usually do, but they don't have to. And the return path header here in the headers is created when the server accepts that email message, and that's actually the envelope from. So that's that initial from address that it saves. So now some basics. We can start to take control of our email environment. And the first step is to work out who is sending email as your brand. You've got your obvious choices, your corporate email, your internal applications, but there's probably a lot of other sources that you might want to consider shadow IT that your IT teams probably don't know about. Your marketing and sales teams are probably using services like MailChimp and SendGrid to send emails to customers. Another big hurdle is SaaS products. A number of these platforms want to send email as your domain. And it's typically the HR ones. Say an employee creates a leave request, the HR system will then want to send an email as that employee to their manager saying, hey, can you approve this? And they're the ones that often get overlooked when we start to sort of work out what's sending email as our brand. In some organizations, the thought of determining all the sources is too much. As I said, most organizations have policies around using their brand, what colors can be used, how the logo can be used. You should be protecting it like any other asset. If you don't take steps to protect it, how can I actually believe that you take security, strongly? How do you actually believe a bank when they say they take our customer privacy seriously? So once we know who's sending email, we can start looking at setting up SPF. And it's an IP list of those who can send email as our domain. It's maintained in DNS. Receivers can look at that list and then reject unauthorized messages. A common misconception with SPF is that it validates the message from header. It's actually the envelope from. SPF has some advantages and disadvantages. We can actually tack different records together, so we don't need to know all of the IP addresses for Office 365 or Google Apps. We just reference to those providers. The limitation here is you only get 10 DNS queries. Some platforms check and stop at 10, others don't. So we need to take a bit of care. Once you've got your SPF records, we can move on to DKIM. DKIM uses digital signatures. It's not quite the same level of protection as, say, PGP or SMIME. These signatures are not visible to the recipient. They're added to the headers by the sending server, and then they're validated by the receiving server. We put the public keys of the sending servers into DNS, and that's how we do that verification. DKIM validates the message from header, so it's actually handling the other from header that we're talking about before. It's going to take a lot more work to set it up. It's a lot more difficult than SPF because you need to make sure that every system that's sending email as your organization supports signing those messages. I had to wait 6 months for one SaaS vendor to get their act into gear, and it was only on threatening that we're going to leave them that they actually finally deployed it. Once you've got DKIM, then we can start looking at DMARC. A lot of organisations are terrified that DMARC policy is going to result in their emails not being delivered to customers. And you're right, you can shoot yourself in the foot with DMARC, but if you take care, you can ensure successful delivery. DMARC builds upon SPF and DKIM, provides more validation that the message from and the envelope from headers are aligned. And the idea is that if a message passes both these checks and the headers are aligned, it's a valid message. Domains can specify different policies. These are actions that the receivers should take when a message fails validation. Senders can also specify if receivers need to provide delivery reports on what they've accepted and what they've rejected. Your DMARC policy is stored once again in DNS. Now you know why DNS is so important to this story. Start with a policy of none, move to a quarantine policy, and then finally onto a rejection policy. Quick note about Office 365 is it actually handles the reject policy as it would the quarantine policy. So those emails will still be delivered to the junk mail folder of a recipient, even if the sending domain said, hey, no, you should reject anything that doesn't succeed validation. I don't know why they've done this. They've just done it that way. Let's just talk about an oxymoron that is bank-grade security. Phishing Scorecard tracks SPF, DKIM, and DMARC configuration of organisations worldwide. 53% of banks and financial service providers here in Australia have no DMARC configuration at all. 38% have a policy of none, and just 9% have a policy of reject or quarantine. Pretty, well, I was going to say something else, but it's pretty bad. How much do they really care about the privacy and security of their customers? They really don't. So almost all software projects depend on other software, and this could be JavaScript packages, Docker images, libraries provided by vendors. And the problem is that we provide considerable trust in these third parties that write these dependencies. We often think that they're better people than us. Bit of imposter syndrome, really. We like to believe that they're not going to introduce malicious code deliberately and that they follow similar security practices to our own. Unfortunately, over the last year or so, that trust has been broken quite a large number of times. February last year, the JavaScript plugin BrowserLoud was compromised, and its code was altered to inject CoinHive's Monero miner. For several hours, anyone visiting the over 4,000 impacted websites inadvertently ran the hidden mining code on their computer. Australian websites included government departments, city councils, charities, disability support providers. Quite a few that actually have access to the metadata retention scheme also run BrowserLoud, which scares the hell out of me. SRI, or sub-resource integrity, is the best defense here. It basically allows a website to tell a user's browser to check the integrity of these third-party assets. If the integrity doesn't match the stored hash, it doesn't load them. In June last year, it was reported that 17 malicious containers were removed from Docker Hub. Some of these images were just harmless and mining Monero. Others created reverse shells or attempted to install backdoors on the host machine. They were available for over a year before Docker pulled them. Estimates are that the attackers made around $90,000 mining Monero from the more harmless ones. As was spoken about yesterday with Sarah's talk, the best protection is a private image repositories where you've validated the security of those Docker images. In July, an attacker compromised the ESLint scope and ESLint config ESLint npm packages. They published a malicious version that would send the contents of the user's .npm RC to the attacker. This file typically contains your credentials to npm. The belief is that they were trying to get more access to even more npm maintainers. These two packages see 3 million downloads a week. They have 31 directly dependent packages and 20,000 indirectly dependent packages. How did it happen? The official story is that the maintainer reused passwords and didn't use 2FA. As I said earlier, not all maintainers follow the same security practices as we do. Just last week, attackers added a backdoor to the Bootstrap SaaS Ruby gem. The great news about this one was that it was picked up really quickly. Somebody in the community went, hey, this code's doing some interesting things, and created a GitHub issue. The developers got onto it and pulled it pretty quickly. And it only took a few hours from initial discovery or initial posting to actually being pulled. Unfortunately, it was still downloaded about 12,000 times in those few hours. We don't have a full breakdown of what happened. There's only 2 developers that actually have push rights to that that particular Ruby gem. We'll find out more in the next few weeks about how this incident happened. And last week, another one last week, was a WordPress developer called PipDig. Was accused of adding a number of suspicious, malicious features to their WordPress plugin. And it's a very popular WordPress plugin. And that included a remote kill switch that deleted all your WordPress tables, just dropped them all. A remote password change function, and it was DDoSing a competitor's website as well. Really nice people. It appears that they even took active measures when they were detected of covering their tracks. They deleted their open source repos, deleted most of the history, and then reposted them up without any of the malicious code. As I said, it's a mistake to trust all of these authors that they're not going to be deliberately malicious. Sometimes authors do turn out to be deliberately malicious and pretty much bastards. That's it for me. I want to thank you all for listening to me today. I hope that you found something useful in today's session and it wasn't too boring for you. I'll be posting up all the contents of this presentation on my blog over the next few days. Thank you all very much for listening to me today.
Well, all right. Good stuff. I've been following that WordPress stuff a little, and it's yeesh.
Yeah, it's a trash fire.
And there's been some real there's been some other ones as well, like WordPress. The world of WordPress is like that trash fire is burning brighter than usual.
Yes.
At the moment. Hey, just a quick announcement too. There's a whole bunch of prepaid merch at the merch desk that people haven't picked up. So if you have prepaid for your merch, go get it. Go get it. And then merch people can relax and smile and all of that. So who's got questions for Kieran? We got one down there.
Kieran, a lot of the stuff that you suggested would require a bit of overhead. Have you got a rough size of a rough guide on the size of an organisation to implement the different levels?
So the question is like, how big an organisation do you need to be to do all of this stuff? Like, because there seems to be a bit of overhead involved.
We have 350 employees right now. I felt it was valuable enough to do it for that. I've done most of these steps for my home domains, my project domains.
A lot of it's set and forget, like
yeah.
on the email stuff.
Yeah, email stuff is pretty much set and forget unless you're adding a new DNS, a new email sort of sending service, and that helps with the shadow IT. DNS is pretty much configure and forget because it just runs itself with the CI/CD.
One thing I want to pick up on though is you're like, don't trust the authors, right? And that goes for things like Docker containers and WordPress plugins and whatever. But that's the world we're in now, right? Where you don't do stuff yourself anymore. You just take all of this stuff that other people have done, you glue it together, and you hope for the best. So, I just wonder if we're in that sort of trap right now where the advice is to do it all yourself, but like no one's got time to do that shit. So we just have to kind of cross our fingers a little bit. Is that
I'd like to think of it as we just need to, every time we bring a new piece of software, be it from one of the big vendors or a small guy that sort of, girl that's coding in their bedroom for an open source project, we need to just build that trust and go through those steps. If it's open source and it's a small code base, take a look at it, see if there's anything that jumps out at you.
No one's got time for that. But yeah, and there's also the problem too, where that single lone coder in their bedroom, you know, might be offered like 1 Bitcoin, or well, actually no, that's a bit high, less than 1 Bitcoin, to sell off their project to someone who says they're gonna, you know, do something commercial with it, and then of course they just, you know, load it up with malicious shit.
And we've seen cases where that's happened, that they've come to, you know, Chrome plugin vendors and gone, here's $30,000 for your Chrome plugin, and if somebody did that for some of my software projects, I'd be handing it over.
Yeah, good to know, man.
Don't use my software projects.
So if you're a Russian gangster who wants to buy some software projects and you know, target all users, contact Kieran.
I don't think many people use my software, so I'm pretty safe.
You're pretty safe there. Got a question back here.
So with the time for that, one of the things from we have is your security is holding us up. What do you usually say, friendly, explicit, or nicely to your employees?
Yeah. So what do you say to the rest of the organisation when they're accusing you of being a roadblock because you might want to look at the horror show shit they're trying to put everywhere in your organisation?
A lot of the time these days, I now just refer to these cases, or I sort of say, hey, remember that time that you were involved in that security breach, or you worked with that customer and you had to work through that security breach because of one of the other developers within the customer, and they start to realise that, hey, we need to do this work.
It seems a good way to convince people, isn't it? To go, well, here's a printout of some headlines for you. Clunk, you know, take them for lunch.
Yeah. And the other thing is, if you can reduce your roadblocks in other places within your IT organisation, that can be a lot easier. And that's why things like DNS control for us, it means that we've got more spare time to do the security reviews and things like that, because we're not trying to manage DNS and all the other sort of stuff that we normally would on a day-to-day basis.
Anyone else? Going once. Going. Oh, we got one there.
It's not a question, it's an observation, because I went through Kieran's process recently working with software, and I didn't have to deal with that. Can you do this for me? No, actually, here's do it self one.
Yeah.
Yeah.
And it was actually a lot less friction than what I was used to dealing with, which was waiting for someone to serve each request. So yeah, I had to go find out how to do it, but I didn't have to wait for someone to get up to a diary or get through it.
Someone who did it themselves. That's
Lionel's one of the developers at Redify, so he's actually one of my customers. So he's been on the receiving end of a lot of this stuff.
All right. Everybody, thank Kieran Jacobsen.